My first assignment when I started working at Transtar was involved with the Bolivar Ferry. And over the years, TTI and I have done different things to try and estimate wait times. When you go to the ferry, you know that you're going to wait, and we're trying to inform the public using different technologies over the years to let them know so that they can make informed decisions about whether they should take the ferry or they should take alternate routes. It is the shortest. It saves about 60 miles taking the ferry to go to Beaumont, Port Arthur area versus I-10, but sometimes the wait it's not worth the extra time that you would be staying there. A little bit about the history of the ferry system. It's been state operated since 1934. Before that, it was operated privately and by the county, and it's been toll-free since 1949. The toll was initially implemented as a means to reduce congestion on the roadways in Galveston County. They carry 8 million passengers yearly, and they have 5 ferries that don't all run 24/7, but only when volumes make it necessary. The picture at the top is actually from, I think, the 60s, and I just thought it was interesting. They've never allowed hazardous materials, and we've had some problems with gas cans after hurricane season. This right here is a timeline that shows just the different things that we've done. Prior to having any type of ITS, the ferry office would send either the sheriff's department or a ferry worker down Ferry Road and down State Highway 87 in Bolivar to see what the queue was like, so that when people would call in, they would know what the wait time was. And from there, they started inputting it into a website where Transtar operators could post wait times on DMS signs. The first cameras that we had were on Ferry Road. They were fixed. They didn't want anyone to be able to pan and tilt them or zoom in on anyone going to the beach. After that, we were able to upgrade them to PTZ cameras on Bolivar and in Galveston. One of the initial problems we had with that was that we were on an ATM network, so the video had to be encoded, decoded, and re-encoded for our network. Once we had all the cameras on Ferry Road, the video was actually only going to the ferry tower, and Transtar had a need to see the video to see what was going on, see if there were incidences. We have things happen in the channel, and they always want to know what's going on with traffic. Initially, TT and I put up a wireless link on the roof of the ferry office, and we were able to establish link back to a text.hub. And after that, we moved it to a permanent location on the actual radio tower. And it was, at the time, it was enough capacity for the cameras and everything that we had, but since we've added some, it's, excuse me, it's been kind of a challenge. We've noticed over the years that sometimes in the morning that due to fog and stuff on the bay, we would have the capacity dropping and the video would start to pixelate. One of the features of the antennas is that it does sense interference and will switch to other frequencies when it's detected, but the frequencies that it switches to doesn't always have the capacity of the frequencies that it would prefer. We did have to replace both of the backhaul to Bolivar and to Santa Fe because of lightning storms. And that just showed the installation that we did in Bolivar was on existing infrastructure, which were illumination poles. Eventually, we were able to extend the fiber from 61st to Seawall with the project that the city of Galveston did to get communication to all their traffic signals. When we did that, I'm not sure if you can see it on that slide, but we had to get fiber from point A to point B to connect the two isolated networks. And once we did that, we were able to have all the video on fiber that's on Galveston, and we were also able to extend the TxDOT business network, which at the time it was on a T1. We started using Bluetooth readers to estimate travel times versus just looking at the queue and doing a worksheet. It is the same concept as what you would see on the freeway. It picks up a MAC address at one location, and then it picks it up at the other location, and once it has enough of those matches, it will determine what that travel time is so that it can be posted on DMS signs leading up to both ferry landings. Right now, we're only using 4 locations for travel times. In the beginning, we had about 8, and we were using those to try to figure out what people's traffic patterns were coming out of the Houston area to get over to Bolivar. The first slide shows the reads, and the second slide shows, the second image shows the actual matches. And they use that to, the orange line in the middle kind of is the smoothed average of what the real expected travel times are. And that's a depiction of how the MAC addresses are actually matched. Of course, that was pulled from a Bluetooth presentation, and the boats don't actually go 60 miles an hour. We wouldn't get there in 1 minute. Actually, that'd be less than a minute. What we've done now, what we're using now is actually Wi-Fi readers. They use the same technology as the Bluetooth readers. It picks up a MAC address from a device that's looking for Wi-Fi and matches it to another device to determine those travel times. But what we found with them is that because traffic is not moving, we actually get we're more successful getting reads from Wi-Fi than from Bluetooth. And on those days, right before July 4th, it was almost triple the number of reads. And the number of matches was actually doubled, which really makes the data more reliable. We've also installed 3 DMS signs that are used exclusively by ferry operations to relay information about if the ferry's closed. There have been oil spills, there have been barge hits in the channel where the ferry is not able to pass. So we have one that is on the other side, on the mainland, so that they know before they even go over the causeway, there's a problem and they can turn around. And that one is, the second one is actually leading up to the landing in Bolivar. And then there's another one that's close to Winnie, like if you were coming out of Winnie and going south towards Bolivar, it would show. If there was a problem, you were trying to get to Galveston, you wouldn't make that 60-mile trip to the landing. The current things that we're doing, we have some full-color DMSs that are being let in 2016 that will be at the landings for traveler information. Currently, we're also having CCTV poles installed to replace the illumination that's on Bolivar. That was a temporary situation, but sometimes our temporary situations turn into years, especially when we haven't had any problems. And they're currently being, actually the locates for those were done a couple of months ago, and they should be doing drill shafts. We've also procured another wireless backhaul between Galveston and Bolivar. The new one will go on the new ferry tower that was installed a couple of years ago. And we just very recently installed an AIS antenna and receiver to pick up information about the boats. And with that, I'm going to turn it over to Tony.
Thank you. Yeah, it's a very challenging environment down at the ferry system, environmentally, and because it's not continuous traffic flow, the Bluetooth and the Wi-Fi systems, we've had to work over the years to smooth out the data that we receive from those systems. About a year and a half ago, though, I became interested in what AIS, or the Automated Identification System. This is a marine system. For those of you not entirely familiar with Galveston Bay, it's one of the busiest ship channels in the world, but it also crosses the Intracoastal Waterway, and so you essentially have an interchange out in the middle of Galveston Bay that is extremely busy. AIS is a method that the Coast Guard requires to identify ships over 300 tons, and they, depending on if they're moving or anchored, they send out position data and status information anywhere from every 30 seconds to every 5 minutes, including the ship ID, the position, the heading, the speed. These are required on boats of 300 tons or more, or all passenger ships. And this is about a 300-ton vessel right there. So that kind of gives you an indication of what size vessels are required to transmit AIS positions. But what this is really used for is collision avoidance. The vessel traffic services, or essentially air traffic control on the water, uses it. They have security issues, search and rescue, and then post-event accident investigation, and then, of course, fleet and cargo tracking. And that's what we'll be trying to do using the system for the ferries. It's fairly simple. There's a receiver, there's an antenna and some cabling. We've got lightning protection on there. We've got an internet connection right now. Since it was just recently installed, we hooked up to cellular and brought data back immediately. We're very pleased. We get hundreds of thousands of data points a day using the system. And then we're starting the process to do back-end processing. It's a collaboration between TTI. We purchased the equipment. TxDOT was gracious enough to let us use the ferry office roof to put the antenna up. It just recently installed, as Valerie said, and again, we're very pleased with the quality of data that we're getting. This kind of gives you an idea of where we're receiving ship data. Most of what we receive is within 20 miles, but we are reading as far away as the coast of Louisiana. It's very interesting to watch the data, but this is basically the intracoastal path, and then you can see out here as ships come in and anchor, we're reading them and then up the ship channel into the industrial areas. We're covering about 1,500 square miles with the system, but there are days, depending on the environmental conditions, that can double and we can see about 3,000 square miles. This is kind of what we see, a snapshot using the marinetraffic.com interface. So we see ships going up the channel, and then we also have a fleet set up to where we see the ferries as they go to the landings or they're docked to the side. We also see a lot of the vessels that are offshore, either anchored or moving in. This is an example of what we'll start to develop over the next several months. This is a map showing a close-up of the ferry operation. You can see here, I think, the Johnny Johnson coming in to the landing. We've got the Stoker and the Deadman docked. And then the DeWitt Greer is headed towards the Bolivar side. But what we'll do is this will give us a real-time indication of how many ferries are in operation. Bill's interested in that information. Departure times, anticipated arrival times, all through a real-time map. And then the ferry operations office themselves can use a lot of this data for performance measurement. And we'll try to work with them on some data interfaces to that. When we went down a couple of months ago and talked to some of the ferry office folks, they were concerned about security. If they have an incident, what we'll be installing is kind of a kill switch function to where at an instant on their direction, the whole system will cease being public. Right now, though, AIS data is public information. Anybody with a receiver can read the information and see where ships are across the world, essentially. And with that, any questions?
Any questions?
You said travel times versus wait times. Why are you using travel times versus wait times on the Galveston Ferry?
You want to take it?
Yeah, I'll take it. Okay. That's a loaded question. David knows the answer.
David does know the answer.
For the longest time, we used wait times because we thought that that was the metric that the public would most associate with the ferry experience. How long do I have to wait, and does it make sense for me to go around through Winnie and High Island to go to Bolivar? That's a very difficult, because of the way Bluetooth technology works, it's a very difficult metric to measure directly, and it has a lot of variance, particularly on the ferry landing where you have a lot of the folks coming through on medical boarding passes. We see a lot of variance in the spread of the speeds in the data that we receive. So what tended to smooth that out, it was going towards a travel time from the start of the queue across to Bolivar, or if you're coming the other direction at the start of the queue on Bolivar across to Galveston. And that really tended to smooth things out and reduce the variance that we saw. It's a more reliable metric. And we haven't gotten any complaints about it, so I think the public likes it. Mike?
Have you actually seen more reliable travel time information being provided, increase in usage of the ferry system, and could it demand more than 5 vessels in this fleet? Is that?
I don't think we've tried to correlate the travel time information with demand for the ferry.
I think the next.
I haven't seen, I manage the ferries, I haven't seen any increased usage based on us providing more information. And I know what you're saying, if you build it, they will come. It's just to let them know, people, there's a line, give them information, so this is what you're getting into.
You take the other option, but you've now built travel time reliability into the ferry system. So,
I mean, what I'm saying though, the statistics haven't increased. The traffic has been basically flat since Ike. It's starting to tick up a little, but it hasn't increased at this point.
Ishmael was the next person that wants to ask a question. Go ahead, Ishmael.
On those times that you delay the travel time, are those messages getting posted automatically, or does somebody actually kind of look at that? Do you have an algorithm already developed that kind of
There,
get that and then post it automatically?
there is an algorithm, and it is posted automatically. There's actually, they've set up a website where they can activate those messages to be displayed or not. And once they activate that algorithm, it's just automatic. And probably in the beginning, it was verified more, but now it's become a pretty common.
I think folks are comfortable with the outputs now. And, yeah.
You have a question, right? Okay.
I just wondered if you were planning on using the AIS data to kind of using your algorithm in some ways so that you know the flow rate basically out of the system.
For the ferries themselves. It's interesting. Since we just got the data, since we just got things hooked up and we're starting to look at the data, we want to see, and it may be a travel time reliability function. There is there's some variance on the trip time between landings. And typically, on average, we think it's about 18 minutes. I think that's about, but depending on what's in the channel and what the ferry may have to slow down or stop or take a more curved route, that travel time could be 20, 25 minutes. I think everybody's happy once they're on the boat, you know,
Yeah, I was
so.
just thinking, you have a queue, and then if you add 2 more boats, obviously, the queue's gonna be faster.
Yeah, one of the things that I've always wanted to do as kind of as a research deal is get demand coming in upstream on Ferry Road, and then knowing the capacity, and then now that we can know how many boats are in real service real time, do some real time queue calculations to see what the average time in queue might be.
Just with traffic count information?
The demand would be traffic count information.